Okay, section 3.2. Section 3.2 is going to deal with the trigonometric functions, the unit circle, and we're going to talk about the different parts of the unit circle. A lot of the basics of working with the values. How to do them by hand without a calculator. You're going to use the unit circle to define trigonometric functions of real numbers. Recognize the domain range of the sine and cosine functions. Find the exact values of the trigonometric functions at pi over 4. Using even odd trig functions. Recognize and use fundamental identities. Use periodic functions or properties, and evaluate trig functions with a calculator. A unit circle is a circle with radius 1, with its center at the origin of the rectangular coordinate system. The equation of the circle is x squared plus y squared equals r squared, which on here would be x squared plus y squared equals 1, because the radius is 1. So this is a unit circle. Unit circle is radius 1. That means the radius is always 1. The sides, if I drew a triangle in any of these parts here, so in other words, if I drew a triangle down here, if I take a squared plus b squared, it's going to equal 1. In a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. Both are given the same real number t. So in other words, t, the radian measure, is equal to s over r, which we know from our previous section. But on here, on a unit circle, the radius is 1, so my intercepted arc is always equal to my central angle is always equal to my arc length, since my radius is always 1. Now the 6 trig functions and their abbreviations. Okay, we got sine, which we abbreviate sin, cosine, cos, tangent, tan, cosecant, CSC, secant, SEC, and cotangent, COT. These are your 3 basic ones, and these are the ones that you probably haven't seen before. If t is a real number and p is a point, xy is a point on the unit circle that corresponds to t, then the sine of t is equal to the y coordinate of that point. Now, here's the deal. Sine of t equals the y coordinate. Cosine of t equals the x coordinate. Tangent t is equal to y over x, where x cannot be 0. And now the sine is always the cosecant is always reciprocal of sine. So if sine is y, cosecant is 1 over y. If cosine is x, secant is 1 over x. And tangent is y over x, cotangent is x over y. These go hand in hand. Now tangent and cotangent, easy to remember, they go hand in hand together. I always think the first letter is opposite. So cosine goes with secant, sine goes with cosecant. Now t is a real number, and we're dealing with the point x and y is at this because my r is 1. It's a unit circle. Use the figure to find the values of the trigonometric function. So like on here is sine of t. Here's my angle. Sine of t is my y coordinate, so on here sine is 1/2. Cosine t is the x coordinate. Now the x coordinate of here is square root of 3 over 2. It's hard to read, but it's square root of 3 over 2. Now tangent is y over x. Well, y 1/2 over x square root of 3 over 2. Now if we multiply 1/2, flip and multiply 2 over square root of 3, 1 over the square root of 3, and we can't have square roots in the denominator. So we're going to get the square root of 3 over 3 for tangent, using these rules as we go through. Use a figure to find the 6 trigonometric functions. Now cosecant is 1 over y. Well, 1 over 1/2, which if we simplify down is 2. Secant is 1 over x, which would be 1 over the square root of 3 over 2, which is equal to 2 over the square root of 3 if we flip and multiply. Rationalize the denominator. So we're going to get 2 the square root of 3 over 3. Now cotangent is x over y, so we get the square root of 3 over 2 divided by 1/2. Flip and multiply, you get square root of 3 over 2 times 2 over 1, which is square root of 3. So we're using our functions to find our values. Now the domain of the sine function and the cosine function is a negative infinity to infinity, the set of all real numbers. So cosine and sine are all real numbers. The range of these functions is the negative 1 to 1. The set of real numbers from negative 1 to 1 inclusive. Now what does that mean? For brackets mean they include negative 1 to 1. Inclusive means include negative 1 to 1. So that means it can take on any value from a negative 1 to 1 back and forth throughout the equation. Now let's talk about trigonometric functions of pi over 4. And pi over 4 is a common value, and we can use anything, but we're just going to talk about pi over 4 right now. We use the unit circle to find the values of the trig functions at t equals pi over 4. We see the point AB right here. Here's our point, here's our arc. Lies on the line y equals x. Thus, P has equal x and y coordinates. And that, in other words, if we drew a triangle here, my x coordinate and my y coordinate are going to be the same. So we got x squared plus y squared equals 1. That's the unit circle. But what we know is that the x squared and y squared points are the same. So we're going to say a squared plus b squared equals 1. Since they are the same, so we can go a squared plus a squared equals 1. Solving it down, we get a, and really we get a is equal to plus or minus the square root of a half. But since a, for example, we'll go back and look at the picture here, a stands for this side or this side. Both would have to be positive. It's a side length here in the first quadrant. Since it's in the first quadrant, a has to be positive, so we're going to say a is equal to square root of 1/2. Now, if we rationalize square root of 1/2, square root of 1/2 is square root of 1 over square root of 2, which is square root of 2 over 2. And that's where we're going to get both sides have to be the same. So x and y are square root of 2 over 2. Okay, that's how we get our values for pi over 4. So x is square root of 2 over 2 and y is square root of 2 over 2. Now to find the values, okay, cosecant of pi over 4. Well, cosecant pi over 4 is 1 over y, so really it's 1 over the square root of 2 over 2, which multiplying by the reciprocal, or flipping it over, square root of 2 over 2, rationalizing the denominator. So we're going to get 2 square root of 2 over 2, which is square root of 2. So cosecant of pi over 4 is square root of 2. And now notice the secant pi over 4 is 1 over x. Well, 1 over x is the same value, so that's going to be the square root of 2. No different. Now cotangents x over y, well, if we take x, square root of 2 over 2, divided by the square root of 2 over 2, anything divided by itself is 1. So cotangent pi over 4 is 1. And now here's some of the rules we can follow. Since cotangent pi over 4 is 1, you know tangent's that. Cosine square root of 2 over 2, so secant square root of 2, sine square root of 2 over 2, cosecant square root of 2. Now when we get into these, we're going to start talking about even and odd functions too. Now even and odd get to be a little more interesting on here, but we know that the only two even functions on these graphs are cosine and secant, and cosine and secant go hand in hand together. They're reciprocals of each other. So cosine of a negative angle is equal to the cosine of the positive. Secant of a negative angle is equal to secant of the positive. So if we ever see a negative angle, we can just make it into the positive. Now sine, cosecant, tangent, and cotangent are odd. It means they're negative opposites of each other. So for example, like here, we got secant. Secant is an even function, so secant of a negative pi over 4 is the same thing as secant of pi over 4. Secant is 1 over x, and we already did this problem, which was 1 over the square root of 2 over 2, which is the square root of 2. So secant of a negative pi over 4 is the square root of 2 over 2. Now sine of a negative pi over 4, and since sine is an odd function, that's equals to negative sine of pi over 4. Sine of pi over 4 is the square root of 2 over 2, so it would be equal to negative square root of 2 over 2. Odd means we just put the negative in front. Some more identities. You'll notice that we have a lot of identities for trigonometry. We just tons of them, and we're going to keep using them. Now, sine is the like I said, reciprocal cosecant. So 1 over cosecant is equal to sine. Cosine 1 over secant. Tangent 1 over cotangent. Cosecant 1 over sine. Secant 1 over cosine. Cotangent 1 over tangent. Now the quotient identities, tangent sine over cosine, and cotangent cosine over sine. So if we know some values, we can work them out very easily as we go through these problems. So let's say here we got, given that the sine of t is 2/3 and the cosine t is square root of 5 over 3, find each of the four remaining trig functions. Well, tangent is sine over cosine, so 2/3 over square root of 5 over 3, which is 2/3 times 3 over the square root of 5. 2 over the square root of 5, rationalizing the denominator, we're going to get 2 to the square root of 5 over 5 for our tangent. Now sine is 1, or cosecant, I'm sorry, is 1 over sine, 2/3. Now flip and multiply is 1 times 3 over 2, which is 3 over 2. Now notice on here that the cosecant is greater than 1. That's okay. The rule says sine has to be and cosine has to be between 1 and -1. The other ones don't. Same rule, we'll see secant is 1 over cosine, so on here we have 1 over the square root of 5 over 3, which multiplied by the reciprocal is 1 times 3 over the square root of 5, which is 3 over the square root of 5. Rationalize. We're going to get 3 square root of 5 over 5. Now tangent's 1 over tangent. Well, we just did tangent a second ago, I think. Tangent is 2 square root of 5 over 5, so it'll be 1 over 2 square root of 5 over 5. Flip and multiply. 1 over 5, 2 square root of 5. Rationalize. So we're going to get 5 the square root of 5 over 10, which square root of 5 over 2, and the 5's cancel off and make 2. Some more identities. Sine squared plus cosine squared equals 1. This is one of your most popular ones. You're going to use this all the time. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. We're going to prove these. Not too hard to prove, but we're going to get to them. Okay, well it says, given that the sine of t is 1/2 and t is between 0 and pi over 2, or 0 and 90 degrees, find the value of cosine of t using a trigonometric identity. Well, what we know is that cosine squared t plus sine equals 1. Now if we go in here, we got cosine squared t plus sine is 1/2, so 1/4 equals 1. Subtract. We're going to get 3/4. Take the square root. That's a terrible square root. We're going to get cosine t is equal to plus or minus the square root of 3 over 2. Now it says t has to be between 0 and pi over 4. It's in the first quadrant. What we know about the cosine is in the first quadrant it has to be positive. So therefore cosine of t has to equal the square root of 3 over 2. Now function f is periodic. It's a key word. We use this a little bit. We don't use it a lot, but it's good to know. If there exists a positive number p such that f plus t plus the angle plus p is equal to f of 2t for all t in the domain of f. The smallest positive number p for which f is periodic is called the period. So what this means is if a function repeats itself after so long, how long it takes before it repeats is called its period. Like on sine and cosine, it's 2 pi. Secant and cosecant, it's 2 pi. Tangent and cotangent, it's pi. That's how long it takes to repeat. But now, if we that's in the basic functions. Now, as we change them, it does change the functions. So like in here, the sine, basic sine function, the period is 2 pi. If we added on 2 pi or subtract 2 pi, the functions would repeat itself. It's the same value. It's kind of like that coterminal part. If we add 2 pi to it, it's going to be a coterminal angle. Tangent and cotangent is pi. If we add pi to tangent, it's going to be the same value. So we got cotangent. So here we got 5 pi over 4. So what we can do is say, okay, this is the same thing as cotangent of 5 pi over 4 minus 4 pi, which is equal to cotangent of pi over 4. That's the period of the function is pi. Now cotangent of pi over 4 we just did a little bit ago. I'm going to go back here. Cotangent of, that's there. Keep going back. Here we go. Cotangent of pi over 4 is 1. So that's one of the rules that we're going to use. So that equals 1. Now cosine of a negative is going to be a negative 9 pi over 4 plus 2 pi, and 2 pi is the same thing as 8 pi over 4, which is equal to the cosine of a negative pi over 4. Now we know that cosine function's even, so that means it's the same as the cosine of pi over 4. And the cosine of pi over 4 is the square root of 2 over 2. As you can see, these will get a little more in-depth as we move along here. It's going to get a little harder, and there's going to be a lot of little rules that you're going to have to remember as we go through them. And this is kind of the same rule again. Period of the sine is 2 pi n. 2 pi n for cosine, and tangent's pi. Same kind of rule. Now, to evaluate trig functions, we use the keys on the calculator that are marked sine, cosine, and tangent. Be sure to set the mode to degrees or radians depending on the function that you're evaluating. You may consult your manual for your calculator. Okay, so for example, if I asked you to find me sine of pi over 4 on your calculator, so I'm going to pull my calculator up here. Maybe. Okay, here's my calculator. First thing I'm going to do is I'm going to go home. I'm going to go to settings, handheld settings. Oops, cancel, not there. Let's go back to settings. Handheld setup. I guess I was there. Can't remember myself. Document settings. There we go. Want to make sure it's in radians. Pi over 4 is a radian measure, so we make sure it's in radians. Then we're going to go back here and we're going to say sine of pi over 4. So I'm going to go sine. And here's a fraction button you're going to get used to, right? Control divide fraction. So we're going to have pi and 4. And I always have to hit control enter, otherwise it's going to give you the exact answer. So we got 0.7071. So my answer here would be 4 decimal points is 0.7071. Now cosecant's a little hard, and this is a nice thing about this calculators are that they do have the function. You don't see cosecant here. So what we can do is just type in CSC. So CSC, parentheses of 1.5, I think it was, 1.5, control, enter, and I get that value, so I think it was 1.5, yep, so it will be 1.00251, so 1.0025, 4 decimal spots. So that kind of finishes off for 2, and let me see what 2 problems I want you to think about today. There's a lot of good problems in this section. Make them a little easier as you go here. Let's do number page 520. Number 25. And 71. Thank you.